Uh, Everyone, welcome to Processing Out Loud here in Twitter Spaces. I'm your host, Marcus Yam. I'm a technology evangelist at Intel. I'm really excited today to discuss a pretty timely topic for the world. It's the phenomenon of deepfakes and the technology Intel has to identify them. Joining me, you've just heard her on the line, just with some really great ideas already, is Ilke Demir, who is a senior staff research scientist here at Intel. And she leads all of Intel's deepfake detection development. And during our discussion today, again, I mentioned this at the top, but if you have any questions for Ilka, please feel free to tweet them out at us and tag us at hashtag processingoutloud, and we'll try to get to them today. So let's kick it off. Welcome, and thanks for joining us, Ilka. First off, tell us a little bit about yourself and what got you. How did you start working with deepfakes?
Hello, thanks for the introduction and welcome everyone to this space. I hope it will be a very fruitful conversation. So, as Marcus said, I am Ilke and I work in AI. So I do computer vision, 3D understanding, geometric learning, deepfakes, generative models, and many related topics. So for deepfakes, it was interesting. So my PhD is in proceduralization, which is finding interpretable representations, finding priors in 3D or 2D data so that we can actually represent that data in a way that artists or creatives or other people can use it. So create more models of the world, basically. So that gives me an eye to see priors or hidden distributions or some structure in data. Then, a couple of years fast forward, I was also working in building deep learning approaches for understanding humans and predicting humans. So how can we understand the gestures? How can we understand the gaze direction? How can we predict what humans will do in the next step with deep learning, etc.? So my proceduralization mind actually let me look for priors in humans. And at that time, deepfakes were rising. They were just getting very realistic, not very realistic, but getting more attention. And I'm like, oh yeah. So deepfakes is a kind of synthetic data that I have been working on for many, many years. And there must be some priors in that data so that we can depend on, right? So based on that, I started looking for different authenticity signatures in deepfakes and PPG signals, which is fake catchers based on, probably we'll talk about it, but heart rate and PPG signals is one of the priors that is really representative of humans, basically. And thanks to my dear collaborator, Umur Aybars Çiftçi, I said, let's look at PPG signals on deepfakes, and that led to fake catcher.
So you've touched on a lot of interesting things here. One is, of course, all your research led you to deepfakes. And I think the big one is the news just came out this week of fake catcher, something that's come out of your work at Intel. And you've used the word PPG. I think it's photoplasmography. I don't even know what my mouth is saying, but is that? And can you tell me what that is and what that has to do with the Intel method of catching deepfakes?
Sure. And as you just tried to say, the hardest part of the research is saying photoplasmography a few times, repeating. So photoplasmography. I'm just kidding. Sorry. So fake catcher is one of the first approaches that is looking at why we are human, what makes us human in all that fake content, in all that synthetic world, and basically. The answer to that authenticity question is in your heart. So when your heart pumps blood, it goes to your veins, and your veins change color because of the oxygen content that is changing. Now, that change is not visible to our eyes. Of course, we don't see the heart rate whenever we look at a video, but that color change is computationally visible, which is called photoplasmography, PPG for short. Now, we take those PPG signals from many different places on the face, and we create PPG maps from their spatial, spectral, and temporal consistencies. And those PPG maps are then fed to a deep neural network to do classification into real and fake videos. This is basically fake catcher, and one of the most important part of the announcement was actually being able to do that in real time. So thanks to all Intel optimizations, we can actually run fake catcher in real time.
So basically, if I've got this right, I mean, okay, I should share like my experience with deepfakes. Luckily, haven't been a victim of anything nefarious, but I've always seen it as an interesting tech demo where you see like, oh, here's this famous figure or political figure saying something that that they really wouldn't have, and I kind of understood it. It was more like a proof of technology or something for entertainment terms. And in my mind, I watched this video that's embedded in a website, and look, isn't that funny? It looks and sounds like the president or something like that.
Mhm.
But so you're saying that based on a video that we look at, it's obviously a fake one, right? It's something that the computer has generated. You're able to analyze whether or not there's blood flow in that character's face, and based on that, you're able to make the determination whether it's a real human or fake human. Am I getting that right?
Yes, you're definitely getting it right. Blood flow is maybe a little bit more general. I would say the heart rate or the consistency of the signals that leads you to find the heart rate a little bit is a better explanation, but it's basically caused by blood flow. So in a very simple terms, normally for real humans, our heart rate in our left and right cheek is the same, right? It is coming from the same heart. But for deepfakes, that's everywhere. Maybe your left cheek is 70, your right cheek is like 200 BPM, or maybe it is like that for 1 millisecond. The next millisecond is changing very vaguely. So that lack of periodicity and lack of structure in PPG signals gives away that it's a fake video.
So this relies on information that, when I watch a video, my eyes and my brain are processing it differently because I'm looking at, like eye contact, mouth movement. Does the mouth sync up with the sound correctly? But you're saying that this is on something that, like a video AI, the fake catcher is able to see it. So does that mean that this information has to exist in a video before it can, I would say, authenticate, right? Because I would say it sounds like the absence of these PPG markers is what you would use to determine a fake. So what if it's a video that is of it's an authentic video? Is there a minimum level of, like, what if the video is super low resolution, like the pixels are really big because the resolution is low, or the video is too short where maybe you need to see, like a certain number of palpitations of the heart? Is there a length or lighting, or what if the video's in black and white, or there's filters on it, Snapchat filters? Does that interfere with how fake catcher works?
Yeah, those are all so many questions that we run so many experiments on. So to begin with the first question about like what happens if the PPG signals are deteriorated on real videos. So we looked at we modeled different noises and we modeled different compression artifacts on real videos and evaluated it with fake catcher. And of course, the accuracy drops a little bit, but we have seen that even if there is like too much blur, the change in those signals are still linear, kinda, in the case of noise. And because of that, they are still consistent. So maybe like we never give a heart. I keep saying heart. I keep going back to the example of heart rate. Fake catcher never says that your heart rate is like 85, but it says that it is same throughout your face. Well, if those signals are transformed in the same way throughout your face, they are still the same signals. But for fakes, even if it is like very low resolution, blurry, etc., none of those transformations will make them consistent again. So that's why fake catcher can work. In another experiment, we actually collected a new data set called Deepfakes in the Wild dataset, and that contains everything from like YouTube, Twitter, research presentations. Like it's a huge data set, or it's a diverse data set of deepfakes that we see every day. And there are so many occlusion artifacts, illumination artifacts, unknown generative sources, large motion, makeup, resolution, compression. All those artifacts are existing in that Deepfakes in the Wild dataset. And even on that dataset, we have 91.07% accuracy, which is very high for an in-the-wild data set, because because fake catcher don't fit to the specific data set that it is trained on. Unlike the blind detectors, it is really looking for these authenticity signatures in real videos and learns to classify them.
So you said it's 91% accurate in those, I guess, I wouldn't call them corner cases, but kind of the less than optimal. And I did read that, you know, the number for that fake catcher that Intel's attaching is 96% accuracy.
Correct.
Can you tell me a little bit about, you know, how did you arrive at that number? What kind of data set did you use to determine, you know, that it was 96% able to identify deepfakes?
So there are several deepfake datasets out there. Some of them are clean lab datasets where we can actually understand and reason our experimentations. And then there are the in the wild dataset that we don't know the sources, we don't know the artifacts, we don't know what is going on, but it mimics and it models the real world. So on the academic datasets that most of the deepfake detection research is evaluated, one of them is called face forensics. And on that face forensics data set, we have 96% accuracy. Now, we also evaluated it with different data sets. For example, deepfakes in the wild, as I mentioned, that is 91.07% accuracy. All of those numbers are actually mentioned in our paper. So you can see that we evaluated it on 4 different data sets with different cross-model and cross-data set results. We can even evaluate the generalization capacity of the model by training it on one data set and then testing it on another data set. And even in those cases, we have high accuracy. So we are hopeful that fake catcher can generalize and is able to provide high accuracy in most of the data sets.
You know, I got to say that with this PPG method sounds like, you know, I wouldn't call it like a silver bullet, but I have to say, like, anything that's, you know, at the accuracy level it is 96%, 91% is quite remarkable. But you know, something that this effective, I hate to say like, oh, but 96%, good job, but where's 100%? What about those other 4? But like, what is it about that 4%? What is that gap? What is preventing it from being 100% accurate?
So a part of fake catcher is actually, so fake catcher needs to find the face, then find the face, then find face landmarks, then extract the regions of interest from those face landmarks, and then extract the PPG signals from those regions, right? In this whole pipeline, the fake catcher is all of them, but the face detection and face landmark detection are also other models, other deep learning models that we are using for finding faces. And those face detection models may fail if there is very large movement of face in the video, if I'm like jumping from left to right, right to left in the video, or face landmarks may change if there is like so much occlusion, or like the hair is all in front of the face, or like other reasons that may make face detection and face landmark detection fails. So in those cases, the faces are not reliably found, and then the PPG signals that you extract from those unreliable faces are, of course, not as consistent as you would expect from a real video. And in those cases fall into our like 4% failure rate.
You've described a lot on how this works, and I just have to think that now that we know how, I mean, at a very high level, I won't pretend I know how fake catcher works at a deep level. You're helping me understand it. But since you have this data set of what to look for in an authentic video, can people not use that same data set and apply it to their own deepfakes to say, I can deepfake a person's eyes or mouth. I'm also going to deepfake all the markers, the blood flow, the heart rate. Like, can those be inserted to just get past fake catcher's filters to verify itself?
Lovely question. I am never tired of answering this question because there has not been an interview or talk or presentation that this question was not asked. So yes, of course. So for fake catcher, it is still very hard to trick it yet, because the PPG signals that we extract and the way that it is formulated is not differentiable. Because it is not differentiable, you cannot just plug it into a generative model, into a generative adversarial network as the loss function, and then try to backprop. So backprop is the thing that makes deep learning approaches work. And if it is not differentiable, then you cannot actually get the error rate in the loss function in a reliable way so that you can find the optimum of it. Because of that technical, sorry, too much technical details, but because of that, you cannot just learn to generate PPG signals in a GAN. That is for the exact extraction. If you want to approximate PPG extraction, then you need very large ground truth PPG data sets which are collected physically from people, and that doesn't exist. There are like 30, 40 people data sets, but they don't generalize to the whole population. You cannot represent the whole population's heart rates with just 30 people, right? And even in that case, even like tomorrow a hospital says, okay, here is your like thousands of people data set, use it for whatever research. Even in that case, we can change the selection of PPG collection points on the face into a probabilistic one instead of like having the predefined points. In that probabilistic way, then the deepfake generator needs to correlate everything on the face with everything to preserve the PPG signals, which is a much harder task than how it is done right now. So it is not possible to trick fake catcher yet. And even if something happens, we have more ammunition in our armory to deal with that.
Yeah, it's funny that you say that, because I have heard from yourself and actually others while reading up about this, that it is, maybe this area of artificial intelligence is kind of like an arms race where, one side develops technology and the other side has to find a way to nullify it or to overcome it. And so it sounds like so is this, it sounds like it's a problem that has many facets. I'm going to ask my question again, but turn it the other way around, because I think that the overall problem, if we haven't stated up front, is deepfakes. Is we're worried that there could be misinformation. You could have someone who is an authority figure or a source of information who says something that was fake, and that way people end up believing it. Could it work the other way? Could we use that same data or that same methodology you have to remove authentication from a real video? Let's say the public health minister says something and it is real, but then there are people who want to work against that message. Can people remove PPG data from a video so a fake catcher would have a false positive? Is that possible?
That's a good question. Well, if you that needs to be done in such a systematic way that you are not adding just random noise, but the actual PPG signals are like disturbed so much that we don't see any spectral, spatial, or temporal correlation. And that's a little bit harder to do in case that we are not exactly looking at the PPG signatures. As I said before in the beginning, for the newcomers, we are using those PPG maps, and on top of the PPG maps, we are training a neural network. That neural network actually learns to deal with the noise and deal with some of the disturbance in the signals, and it looks both the frequency and frame to frame changing and spatial correlation of all of those different PPG signals. So to structurally break all of those consistencies is still hard to do.
And it sounds pretty computationally intensive. So obviously this is a technology that you developed inside Intel. Are there any specific Intel technologies that supported the development and also the functioning of fake catcher? Like what kind of machinery, what kind of technology do you use to make this run and make it work?
Absolutely, absolutely. So the original version of Fake Catcher is as a research product, not real time at all. So our team in Intel, we took Fake Catcher and we did so many optimizations using OpenMinnow AI models, using Intel Deep Learning Boost framework for libraries for inference blocks for all three of the networks within Fake Catcher. We use Intel AVX 512 for, again, inference blocks and AVX2 for media processing blocks. And we implemented this all on top of OpenVisual Cloud stack so that it provides a platform agnostic way of deploying this platform to any CPU, VPU, GPU platform. So it is pretty modular. It is real time and it is high accuracy. And what else we want? Sorry. Maybe I should also say that we actually benchmarked it on Intel Xeon third generation scalable processor, which is codenamed Ice Lake. Probably you know that better.
Mm-hmm.
So on Ice Lake, we can go up to 72 concurrent deepfake detection streams, all running at the same time, looking at many deepfakes at the same time. So if you want, we can also it's one of the presentations that I have done, but we have a detection wall where you can see many deepfake and real videos running at the same time, streaming at the same time, and the detection inference is also running at the same time. So you can have that sci-fi big screen of deepfakes running at the same time.
So, so when you said when you say 72 streams at once, is that like this Xeon Ice Lake?
Yeah.
Is that kind of like watching 72 different TV channels or Netflix shows all at the same time? Is that what that means?
That is exactly what it means. But instead of just watching, you also see whether it is fake or real as a real-time indicator on the screen with confidences changing in every 2 to 3 seconds.
I see. And you say this project started out not as a fake catcher, or at least what it started as wasn't real time. What did it take to have something that needs to analyze so much data to make it work well, from something that you need to analyze after the fact to work in real time? How big of a leap was that?
Oh, that was a huge leap because currently, this is the world's first real-time deepfake detection platform. And as we see more and more deepfakes coming out, it shows that we really need it. And that was a huge space in the space, huge emptiness in the space. I think the most important thing that made it happen is the cross collaboration culture that we had. So the co-inventor of Fake Catcher, Dr. Çiftçi, hopefully he's also on the call. But anyway, he is super collaborative with the Intel team. Like whenever something is needed, the team comes together and works out solutions. Then we have a very supportive Intel initiative that is called Trusted Media. And in Trusted Media, we had very open-minded people that we were co-leading the space. I hope Carl and Satyam and all others are also hearing this, that Fake Catcher and real-time deepfake detection is now being released. Anyway, so I think the most important part was collaboration. And on top of that, of course, the Intel technologies that I mentioned, especially the AI optimizations, especially how OpenMinnow models work very coherently with Xeon architecture, that is like the leap that provided the real-time and 72 concurrent streams. And hopefully, we are also benchmarking for future products. And on those, we even see much more much more performance improvements up to 2x, etc. But I don't want to comment on that for now. But I think the carrying the Fake Catcher to create this real-time platform is really enabled thanks to the Intel AI optimizations.
Yeah, and of course, you mentioned DL Boost and AVX 512. These kind of extensions, really help multiply the power of these processors.
Mhm.
You mentioned collaboration. So I did read in the announcement that Fake Catcher comes out more than 8% ahead of the other algorithms in the next best performance. So it sounds like you said, collaboration is very important, but it sounds like Fake Catcher isn't the only deepfake detector out there, which actually I kind of like. I like that there's competition because I would ask you, hey, could we use PPG to fake a video? I kind of like the idea that right now everyone is approaching it from, or I'm assuming that other other deepfake detectors have different approaches. So, first of all, I want to know, is my assumption correct? And the second part follow up to that is, obviously there's a bit of competitive spirit if you're saying Fake Catcher's 8% ahead of the others. But is this an area of competition between like corporations like Intel and others, or like you said, collaboration? You're a researcher. How much of it is cooperation between different researchers to really, for the greater good of catching deepfakes? Sorry, it's a long question, but what do you think?
Okay, um, I will, I will reply that question in three parts. First part is comparison to other networks. So we first compared it to existing like very deep and complex networks, and we saw that the PPG map representation and fake catcher is better than them with a significant difference. Then we looked at the actual deepfake detectors that are trying to find some other signals, like what I will call as like blind detectors, which are looking for artifacts of fakery, like is there symmetry artifacts, is there boundary artifacts, etc. So we compared fake catcher with those, and we saw that like those blind detectors are more susceptible to adversarial attacks. They cannot generalize over different data sets, and they cannot be used for different domains, but fake catcher was much better in all of those aspects. So in that case, like fake catcher, you can depend on fake catcher very nicely. So the second part of that question is that can we actually use those different detectors in collaboration, right? Not collaboration, maybe in the sense that like academic or industry collaboration, but collaboration of all those deepfake detectors. Well, we actually have some work for that. So probably, as you have seen also in the video, we developed other deepfake detectors based on the priors that we saw in deepfakes. One of them is eye gaze based detection. So instead of so we are looking for priors in data, right? And we saw that normally humans, when we look at some place, it's going to converge at one point. Or even if we are looking somewhere far, our gaze vectors, if we are shooting rays from our eyes, they will be divergent but coplanar. But for deepfakes, they are everywhere. It's like googly eyes. We don't see it immediately. It is subtle, but they look everywhere. So based on that, we extracted some gaze signatures that are including gaze vectors, 3D gaze points, eye size, pupil size, iris size, area, etc. We collected all of them in gaze signatures, and we trained a neural network on top of gaze signatures to classify them in fake and real videos. On top of that, we have other deepfake detectors that we developed. I won't mention all of them, but the idea is in a deepfake detection platform, we can actually combine all of these different deepfake detectors that are looking at different signals or different priors, and that would provide an algorithmic consensus over this whole problem, and it would also inform the users a little bit better, saying that, see, like fake catchers thinks it is fake with this percentage, but eye gaze based detection thinks it is fake with this percentage. They agree, great, it is a fake. If they don't agree, we try to understand and extract interpretable representations about why they don't agree, what can be improved, etc. So that is the second part of the question, that we ultimately want to ensemble all of those networks, all of those detectors into a huge platform to provide algorithmic consensus. Now, the third part of the question, the collaboration between academia and industry. not like for deepfake detection, there are some collaborations, but I want to take a step back and mention a bigger collaboration, let's say, but a bigger issue. So for now, we can try to understand all the different fake media, all the different synthetic media around us. But in the long term, we also want to enable content creators, enable artists, enable studios, enable everyone that we that is using or creating synthetic data in a way. And for that, media provenance carries utmost importance. Media provenance is providing information about the origins of data, about like who created, why it was created, how it was created, was the media created by with consent, etc. And carrying that information throughout the life of media. And we want to develop approaches for media provenance using AI, basically. That's the research part that I'm interested in. On the collaboration part, Intel is a part of C2PA, Coalition for Content Protection and Authenticity. And under C2PA, there are many other companies like Adobe, Microsoft, and others. I don't remember them, sorry. In that consortium, in that coalition, all of the brightest minds are providing open technical standards, policies, and basically thinking about what we can do for media provenance in a collective way so that the future of media is more trusted.
Well, that's good to hear. That, I mean, there's a little bit of co-opetition among there, but I'm glad to hear a lot of those partners are working with Intel on that. A lot of things you mentioned about gaze detection, those things, these are all, I find, that's information that's embedded in video, right? It's visual information you can analyze. I don't know, on a pixel level or how that works, but the other part of it, and I'll actually point to, for anyone who's listening, they haven't, there was a video that we released on this. And in the beginning, Ilka was talking, introducing the video, but it wasn't her. It was a deepfake version of her face, but it was her voice. So I want to ask about, obviously there's so much work, even as humans, we get so much of our information visually, right? So if the person looks the part, maybe that's, it lends more credence in sounding the part. But I think that's another part of it. If it wasn't your voice, deepfakes are two things, right? If someone actually said something and they just made a fake face to go with it, they still said it. What is there? What's your work, or what's your opinion on or tell me more about deepfaking video versus audio? Do you do any work on the audio side, or is deepfaking audio a problem?
Yes, definitely. Deepfakes with synthetic voices are also problematic, and I think there was an example of it that someone deepfaked the voice of an investor for a startup, and the CEO of the startup was forced to give some money or something. There was a story like that. I don't want to misquote it, but basically, because of a deepfake voice, someone gave millions of dollars to someone else, and these things are happening. So deepfake detection using voice clues, audio clues is also important. And our upcoming research that I don't want to disclose it now, but our upcoming research is looking at those multimodal spaces, about how can we correlate the video and audio and maybe the speech and maybe the sound, or maybe the higher level signals like how the breathing patterns are correlating with heart rate or something. So we want to explore all this multimodal space so that not only visual defects, not only image and video defects, but also audio defects, or also like higher level hybrid defects, we can find and process and give better information about them.
Yeah, and I think on just kind of a side tangent on I don't know if it's a deepfake audio, but I read recently that the iconic voice of Darth Vader, voiced by James Earl Jones, he has worked with Lucasfilm and Disney to give those people there the information, his voice information, that they need to, I guess, have the voice of Darth Vader live on for generations, after he's available to do that. So I think that tells me that, at least, for a Star Wars like myself, I'd say not all I don't know if it's deepfake, but not all this technology is bad. So I want to, we've kind of approached this conversation, be like, oh, how do we source out the bad things? How do we weed out the bad things? But are there any specific applications where this type of technology, um, like deepfake, maybe both audio and video, that are positive or beneficial to society? Like, how do we use this technology for good?
Oh, excellent question. I love this question. I also want to, by the way, enable the audience to ask questions. So if people are just joining, you can ask the questions on Twitter using the hashtag processing out loud. So hashtag processing out loud question, we will answer it. Okay, back to the answer. So as the responsible AI team in Intel Labs, that's our job. So how can we use AI in a responsible way, and how can we use AI for good? And of course, that encapsulates how do we use deepfakes for good. So historically, the evilness, the bad part of deepfakes is that they are trying to they are trying to impersonate someone one-to-one. So making someone saying things they never said, making someone do things they never did, etc. So if we can somehow eliminate this impersonation aspect and make sure that the person that is created is a new person, then we can actually use deepfakes for good purposes, because it is a way of actually creating synthetic data, and when it is used good, it improves our lives. So towards that, what we did is we looked at deepfakes with about like how we can do privacy enhancing deepfakes. So we have tons of online photos, right? Like all of us have many photos that is either captured with or without our consent, or distributed with or without our consent, but we exist in digital platforms. And maybe you don't want to be there identified as yourself in some of those photos, but it's not in your control because you don't have control over your face, right? So the approach that we proposed for that problem is called My Face, My Choice, where we give power to everyone over their face, and the choice to appear in any of the photos that they want. And in the other ones that they don't want to appear, they are deepfaked. No, wait. We are using deepfakes for good, but we are using it with guarantees. So the first thing is that we are using source images as synthetic images. So the face that we are replacing your face with is actually a synthetic image that is nobody, that doesn't exist. Second, we are lifting all of these faces to a face manifold. Just imagine that we can measure the similarity of faces in a special place called the face manifold. And in that space, we are selecting the face that is the most dissimilar face to yours to change your face with. And what is more is that instead of selecting the same face every time, we are selecting it within a threshold. So you are deep faked with someone else anytime that your another face that you don't want to appear emerges in the online platform. Now, we use this approach and we evaluated it on a data set, and we found out that the current popular face recognition algorithms are fooled by 61% when we use My Face, My Choice, which means that you won't appear without your consent on online platforms if My Face, My Choice is implemented.
So that sounds really beneficial to people, right? Because like you said, I think one of the steps into these controlling, I guess, even fake faces. That's not even talking about the fake or disinformation, but it's for people to have control over where their information appears. So I think that gets to all these things sound great, very promising. And it sounds like, even in all the media we consume, not even TV, on like online video streaming services, but you've described fake catcher can run on Intel hardware to analyze in real time. I think that's really impressive. Is that you can do this in real time. So if someone's doing a live stream, a deepfake live stream, you can detect this in real time. Are there plans to 72 streams at the same time? Sounds like there are media and social platforms out here that can really use it. Are there plans for this technology to get out there? Is there a roadmap of when the world gets to put this to good use?
Very, very beautiful question. I want to ask this to the world. Like, are you ready for fake catcher? I want to ask this to everyone that is listening. Like, are you ready for using fake catcher? No. So sorry. So there are different types of customers that are interested in fake catcher. We categorize them in 4 categories. One of them is of course, social media platforms. So we keep seeing all those deepfakes harming and spreading misinformation on many platforms, including the one that we are on right now, I guess. And, can we actually implement deepfake detection into those platforms where instead of on ingestion time, there can be the fake catcher can run and there can be an indicator of fakeness or authenticity saying that, let's say, with 95% confidence, we believe that this is a fake video, like believe it on your own discretion or like share it with your own will, etc. So that is the first kind of customers that you may see fake catcher with. The second one is mostly like broadcasters and news organizations. So they have so much third-party content, and before actually making a news, before actually making a piece, they need to run these content verification algorithms to decide whether it is a fake video or a real video. And currently it is mostly done manually or done with offline systems that you wait forever to get a result. Fake catcher or the Intel's real-time deepfake detector does it in real time, so that is very useful for them. The third type of customers is AI for good organizations or nonprofits, where they want to democratize the use of deepfake detectors to everyone in the world. So if you are an independent journalist, if you are just a curious mind, if you are someone that suspects a video is fake, then those organizations can use enable deepfake detection to everyone. And the fourth category is a little bit different. It is like a higher level view of the whole trusted media project. So as I said before, with good deepfakes and with responsible generation of deepfakes, we want to enable creatives, visual effects artists, people that create content to be able to use those generative adversarial networks or generative models to do deepfakes for good. And how do we enable them? How do we develop media provenance approaches? How do we authenticate them? How do we help them? So the fourth type of customers is mostly for content creation tools or content creation companies that we can actually integrate our media provenance solutions with.
Sounds like there's a lot of use for this. So if someone is interested, any of those parties, any of those groups that you've just defined, or even those groups that you haven't even thought of yet, how do they get in touch with you or someone at Intel Labs to be able to work with fake catcher?
Well, they can always drop me an email, ilke.demir@intel.com. You can actually see our videos, and if you have specific business inquiries, we would be happy to talk because, we have a customer-ready pipeline. It's just waiting to be deployed into the workflows of our customers. So come find us and we will work. And I think we're also open to provide some support during deployment into your workflow. So we are open to all of those discussions.
Great. Now, I'm almost at the end of my questions, and we're almost at the end of our time, but we do have a listener question coming in from Mohammed. I think I may have touched on this earlier, but this definitely seems like one of the hottest questions that you field. So I'm just going to read it here, and maybe you can, just quickly summarize maybe your answer from earlier, or if there's some additional insight. So his question is, how do you deal with lower quality media, especially for audio? And also, have you done anything on liveness detection for the KYC or know your customer and remote verification?
Those are great two questions. I will go with the easier one, which is the second one. We haven't done liveness detection, but basically what fake catcher is looking at is PPG maps, which is the blood flow. So not fake catcher as is, but the underlying PPG maps that fake catcher is knowing, fake catcher is using, is can be used for liveness detection and for remote verification. Indeed, the PPG signals have been used in medical literature for some time, for maybe 10 years now, and it has been used for remote patients monitoring and knowing from videos if the heart rate is still good, etc. There are other signals for that. Like I have been talking about PPG, but there's also the ballistocardiography BCD signal that is from like sleeping patients, or like very still frame, very still videos, etc. So all of those have been used for liveness detection in the literature. There are papers for that, so it can be used for that, definitely. For the first part of the question, I would love to give you a much data-driven answer, but I don't have one right now because we are just in the beginning of our multimodal research. But rest assured that whatever we are doing in the audio domain, we will follow our like rigorous experimentations in the video domain with like noise, with lower quality, with different frequencies of voices, with different speech patterns, with all the different variants in the audio domain. We will definitely do all the experimentation in that space. So hopefully in short time I will be able to answer that question.
And we want to thank that listener for the question. And if that question, I know you answered it from the audio side, which you're working on, but for lower quality media on video in terms of like length, resolution, if you didn't hear that answer, I did pose it earlier in this. So, if you're able to, if you can go back and listen to this after the fact, that was one of the questions, and I guess the first half of our conversation. So, I guess I want to know what's next. What is next for Fake Catcher? And I think you talked about audio, but is there something you can share with us today on what is the next step?
Oh yeah, absolutely. Before I do that, I will remind the hashtag again. Hashtag processing out loud for questions. Processing out loud. I love how rhythmic that hashtag is, by the way. Anyway, so next, for deepfake detection and responsible generation, as I said, one direction that we are pursuing right now is multimodal. So multimodal detection, how can we correlate like higher level signals and human priors in audio, speech, video, and like other signals. Like there is a deepfake detection paper based on emotions. So we always pose our papers as questions. So we ask like, where do deepfakes look? How do hearts of deepfakes beat, etc. So we have seen a paper that is saying like, do deepfakes have emotions, for example? So we are trying to look all the human aspects in deepfakes in a multimodal setting. So that is one of the directions that we are pursuing. Another one is actually in the generation space, about how can we do responsible generation in a way that it puts theoretical bounds and theoretical trust metrics about deepfakes being really good. There was a website, there is still a website that says like, this person does not exist, and it is all with it's all synthetic people with which doesn't exist, which are created by StyleGAN, or which are created by generative adversarial networks. But there is also a study that is saying that these people actually do exist because they are very similar to some samples in the data sets. And we don't want that to happen. We don't want to say, okay, this is a completely synthetic person, then realize that, oh, sorry, it really looks like this real person. We don't want that. So we want to put those trust metrics into generative network, into generative approaches. One other thing that we tried in that space is actually making human soups. That's also a new thing that we tried. So we took, let's say we take your eyes and my nose and let's say Pat's mouth. we try to put all of them together so that we kind of guarantee that the person that we are creating is not exactly replicating anyone one to one as by design. So that is one of the other things that we are trying. So as I said, like multi-modal detection is one, responsible generation and the trust metrics is the other one. And of course, for media provenance, we also want to find ways how we can apply provenance in a way that it is not in a certification. It's not like some higher server or some higher up system is authenticating. We don't want it to be like that. We want the media to be self-sufficient. If there's authentication, if there's watermarking, if there's anything that is giving provenance information about that data, we want to be able to integrate it or embed it in the data so that that data is basically saying that it is authentic, saying that why it was created, how it was created. And we can actually do that by exploiting some of the GANs, but I want to talk more about that. So these are the research next steps. And if anyone in the space want to collaborate on those, then I am super open with that. Just like reach out to me and we can talk about that. For Fake Catcher, as I said, everyone is ready to be deployed into a system. And hopefully we will see Fake Catcher and real-time deepfake detection on many other platforms.
So that sounds like a great place to leave. We're almost out of time, so I want to close with actually one last listener question, which I think is a great way to tie things up. And this question comes from writer Jan C. Will this technology be available for consumer access in the near future?
Hopefully, as I said, the definition of consumers in our case is mostly those companies in different categories that I mentioned. If the question is more towards like it will be open to public, that's another question. So actually the whole real-time deepfake detection pipeline is almost completely created with open source tools. So the face detection and face landmark detection is open source models in OpenAI Model Zoo. The Open Visual Cloud is an open source platform. The DS streamer and Intel optimizations that I mentioned before are also open source. The only part that is not open source is that the PPG map creation and PPG classification network. Although I had that whole discussion about how Fake Catcher cannot be tricked yet, we still don't want to open source the code itself so that like maybe people will reverse engineer something to decrease that yet time like cannot be tricked yet time a little bit. So that's the only part that is not open source yet in terms of making it public. For customers, as I said, we are in conversations with multiple customers about how we can deploy it into their workflow, and some of those customers may be able to open it to more of their customers through an API or through a query system, etc. This is still going on, but incredibly good question. I am looking forward to give you a concrete answer.
Well, thank you. We are way over time, which I think is just a testament to how interesting and fascinating and how much you're willing to share with us, Ilke. I really appreciate it.
Thank you. Yeah, it was an awesome conversation, and thanks everyone for the audience collaboration. I really like it, and I am also getting some other congratulations and messages. Thank you for whoever is reaching out to me, and yeah, hope to see you all in more Fake Catcher news or more deepfake detection or generation news.
Thank you. So everyone, that wraps up today's episode of Processing Out Loud. Again, I want to thank Ilke Demir for joining us, and for Intel, I'm Marcus Yam, and thank you all for listening.